Hi everyone, this is Mr. Hall and this is a quick video about significant figures. This is something which is pretty important actually in chemistry when you're doing quantitative chemistry. It becomes pretty important when you first start learning about it in sort of GCSE, sort of pre-16 level, and then when you go into A level it becomes even more important, and you have to do some more sophisticated stuff when you're doing calculations. So hopefully this will just sort of be the basics of what you need to know, and there'll obviously be overlap with what you do in mathematics, so it should be familiar from that too. So in terms of what I'm going to try and achieve in this lesson, there's basically two things I want to teach. I want to go through how you determine the number of significant figures in measurements, and also how to round numbers up or down to a given number of significant figures. As I said before, lots and lots in common with what you've learned in maths probably before. So first of all, let's think about weighing something. Let's say you're weighing this horse, and let's say there are two different ways in which you could weigh this horse. Now, one of the ways in which you could weigh the horse is by using like normal scales, and they probably have to be quite large scales in order to do it, and it'll be quite analog, so you'd get a number which would be determined by where the dial lands. And then the other way of doing it is by using a more digital measure, like putting it on like a digital scale and getting a result out of that. Now, out of these two, you're going to get sort of two very, very different looking numbers. On the one hand here, with this scale on the left-hand side, you might get a mass, and it will probably hover around the 450 mark, although if it's not kind of quite at 450, let's say it's sort of between 450 and 440, it might point over there in terms of how it looks. Whereas over here on this one, the electronic scale, you might get something to a lot more details. It might say something like 8.2 grams or something like that. Okay, so you might get sort of one of the two. So there are two different ways in which you can get different levels of precision on your numbers, and that directly relates to the idea of significant figures. Now, significant figures, it basically indicates the precision of the measured data to anybody who looks at that data. So for example, if I had a weight and I measured it as being 1,100 grams, that would mean that the mass has been rounded to nearest 100 grams. It might be 1,085 grams or 1,112 grams, but it's been rounded to the nearest 100, which in this case is 1,100. However, if I measured a weight as being 1,100.0 grams, that means it's been measured to the nearest tenth of a gram, basically because of this 0.0. Now, although the numbers look exactly the same if you put them inside a calculator, they actually mean very different things because they are referring to different levels of precision. And the second number that you've got over here is far more precise than the first one there, and that's directly related to the number of significant figures it's got. So the more significant figures you have, you're probably more likely to have a much more precise number. So, what are significant figures? Now, there are a few rules you have to know, and I'll go through each one at a time. Now, zeros appearing between non-zero digits are significant. So, for example, if I've got the number 40.7, this zero here is significant. So this has 1, 2, 3 significant figures. As a second example, let's say I've got 87,009 kilometers. I've got 1, 2, 3, 4, 5. I've got these two zeros wedged between two numbers that aren't zero. Therefore, they are significant. Therefore, this whole number has 5 significant figures. So that's rule number one. Rule number two, and by all means make notes of these rules as I go along. The second rule is zeros appearing in front of all non-zero digits are not significant. So for example, if I look at this number here, I've got 0.095897. Now these two zeros come before the non-zero numbers come into play. So these we can ignore in terms of significant figure counting. However, these 5 obviously starts off with being non-zero and carry on like that from there. So these 5 are significant, so therefore this whole number's got 5 significant figures, pretty precise. As a second example, I've got 0.0009. These 4 zeros here, there's no non-zero numbers between them or before them or after or anywhere. So those 4 we can ignore when we're dealing with significant figures. So this number only has 1 significant figure. Okay, now rule number 3. Zeros at the end of a number and to the right of a decimal place are significant. For example, if I've got 85.00, that has 4 significant figures. Now it's important that the zeros are after the decimal place. Okay, and I'll go through some examples in a minute of where sometimes those zeros cannot be significant. So that's got 4 significant figures. You've got your 1, your 2, your 3, and your 4. In my second example here, I've got 9.0000000000. that has 10 significant figures because the first one is there. Then because it's after a decimal, these are all significant. So 3, 4, 5, 6, 7, 8, 9, and 10. They're all significant, and that's how you get your 10 significant figures there. The fourth one I want to talk about is zeros at the end of a number, but to the left of a decimal point are not significant. Now, the decimal point cannot be there for them to not be significant. For example, if I got 2,000 meters, these three, there's no decimal there, therefore we would consider this number to only have one significant figure, which is that one there. These we can ignore, okay? However, if I had 2000.0, because I have the decimal point followed by a 0, so that decimal point changes everything. So now this would have 1, 2, 3, 4, 5 significant figures. So decimal points are really important when you're dealing with significant figures. Okay, so let's go through some examples. So I've got a list of numbers here. You may choose to pause the video if you want and have a go at these before going through the answers, but I'll just go through them now just for your benefit. So this one here, I've got 0 in between two non-zero numbers. So this is 1, 2, 3 significant figures. This one here, I've got 2 zeros at the end, but there's no decimal. So I ignore those. So this is only one significant figure. These three, you'll notice that you've got zeros before any number. So irrespective of the decimal, these zeros are before any non-zero numbers. So this has only 2 significant figures. Over here, I've got 1, 2, 3 significant figures. This 0 still counts in terms of significant figures because it's after a decimal. Over here, I've got 1, 2, 3, 4 significant figures. Again, the 0 is between numbers, so it's significant. These zeros I can ignore because they're before non-zero numbers. So this has 3 significant figures. This number has 1, 2, 3, 4 significant figures. Again, the zeros are at the end, but they're after a decimal. That's the key thing. This number here, the zeros are wedged between non-zero numbers, so they are significant. So I've got 1, 2, 3, 4, and 5. And then the penultimate number here, all these zeros are before a non-zero number. So we can ignore them when we're dealing with working out the number of significant figures. So this is only 1. And then finally, all these zeros, they're after a non-zero number, but they're after a decimal as well. So they do count. So this has got 1, 2, 3, 4, 5 significant figures. So hopefully you got that right when you went through it. And the final thing I want to talk about is how you round significant figures, which can be quite tricky. Now, when you're rounding significant figures, there's 2 rules that you need to follow. So the first rule is, if the digit after the last retained digit is greater than 5, then you increase the last retained digit by 1. Okay, so for example, let's say I have to round this to 3 significant figures. The first thing I find is I find out what the last digit is that I want to retain. It's 3 significant figures, so the last number I'm going to retain is this one. Now you can see that 6, it's bigger than 5, at least bigger than 5, therefore I have to make this increase by 1, therefore it will be 42.7, because I've rounded this number up, so 6 to 7. However, if I've got to round it to 2 significant figures, again I count 1 to 2, and I look for the next number here. Now this is 0.6, and that's bigger than 5, so now I have to round this up to 43. Okay. The final rule around rounding is if the digit after the last retained digit is less than 5, then you leave the last retained digit as it is. For example, if I've got 17.32 and I want to round this to 3 significant figures, that's my first, that's my second, and that's my third retained number. That's always the first thing you should look out for. I look for the next number after that. It's a 2. It's not 5 or bigger, therefore this 3, I keep it as it is. So I get rid of that number because I don't need it, because I only need 3 significant figures. So my rounded number is 17.3. As another example, if I want to round this to 2 significant figures, again, 1, 2, this is my third number, and you can see that this is 5 or lower, therefore I get rid of them. This doesn't change, so rounded it's just 17. Okay? And then if I was to round it to 1 significant figure, sorry, you can't quite see that, I'll just move this. If I was to round it to 1 significant figure, again, I look at my numbers. This is my first, and this is my second. Now you can see I only want to keep this one, but I look for the next number, which is here. It's bigger than 5. I would get rid of these. This is bigger than 5, so I have to round this up from 1 to 2, so that would be 20 meters. Okay, again, that 0 is non-significant. That is a 1 significant figure number. Okay. So just going through a few more examples here. If I was to round this number to one significant figure, I look for where one significant figure is, which is there, and then I look for the next number. I can see that it's bigger than 5, so I have to round this 3 up to 4. Everything else we get rid of and we round up, therefore this will become a 4 and everything else just becomes 0. So that's a one significant figure number. Let's try a few more. If I was to round this to 3 significant figures, this is my third, so I look for my next number. I can see that it's lower than 5, so this stays as it is, the rest becomes zeros, so that would be 378000. If I had this number here, and I want to round this to 2 significant figures, I look for my second significant figure first. This doesn't count, this doesn't count, this doesn't count, because it's before non-zero numbers, so it should be that number. I then look for the next number. It's bigger than 5, so I have to round that up. Therefore, to round it, it would become 0.0029. And then if I was to round this to 3 significant figures, I look for the third significant figure. This and this and this doesn't count because they're before non-zero numbers. That's my first, that's my second, this is my third. I look for my next number, which is over here. I notice it's bigger than 5, so I go back to this digit. I have to increase that by 1, so it goes up to 0.00209. And that's it. So I hope that's been helpful, and best of luck with rounding your numbers to the correct number of significant figures.